Okay, so here we go with the solution for 2019 number 1. And this is one of those in-out questions. We have the rate at which the fish are entering the lake given by E of t, totally a calculator question, and the rate at which the fish leave the lake given by L of t, both measured in fish per hour, and t is hours since midnight. So how many fish? Now remember, when you're given a rate and they ask how many, it means we're going to integrate. So to get your credit, the number of fish, you have to write down the integral. And it's how many fish enter the lake. So it's the integral of E of t dt. Make sure you include the dt. When I first wrote it, I did not. From 0 to 5. And this is a pure calculator question. Put it right in your calculator. Put your E of t in y1. Make sure you are in radian mode. And there we go. We have our 153.458 fish, but it says to the nearest whole number. So this is one we have to round, okay? If it didn't say to the nearest whole number, we'd just go 3 decimal places, but got a round. So there's part A. Part B, average number of fish. That's the average value. Okay, the average number of fish that leave the lake is the average value, average number of fish that leave the lake per hour is the average value of L of t, because L of t gives us the number of fish that leave the lake per hour. We want the average value of that. Average value, remember, is 1 over b minus a, integral from a to b of whatever function we're finding the average value of. So in this case, 1 over 5 minus 0, integral from 0 to 5 of L of t dt. That's all you have to show for work. Again, put it in the calculator. This one does not say to round. So 3 decimal places. You could round to the 3rd decimal place or just truncate it. Part C, at what time between 0 and 8 is the greatest number of fish in the lake, and justify your answer. So let's think about this. This is a closed interval. The greatest value is going to be, that's our maximum value. It's either at an end point of the interval or at the point in the interval where the number of fish entering is equal to the number of fish leaving. So first thing we have to do is find where E of t equals L of t. And again, in the calculator, put one of them in y1, put the other one in y2, look for where they intersect. They intersect at t, or x, equals that value, which I store in the calculator. On the calculator, once you have x, once you have your intersection point, go back to the home screen and just hit x store alpha a, and it's stored in a. So now I set up a little chart saying, all right, I know I have to know how many fish at 0 hours, at a, and again at 8. So the number of fish is going to be the integral from 0 to whatever time of the rate at which the fish enter minus the rate at which the fish leave. Because if you think about it, how many enter minus how many leave gives you how many fish are actually there. So for the first one, we're doing the integral from 0 to 0, which is just 0. Second one, we do the integral from 0 to a, and here's where it's important to store that value, because you cannot round the time. That's not your final answer. You have to use that whole thing. So if you want to type that whole thing in as the upper bound for your integral when you do Math 9, that's fine. I think it's easier to just do 0 to a of E of t minus L of t dt, and we get that value. We do the same thing, but going from 0 to 8 to see how many fish are in the lake at the end of the 8 hours, and we get that value. And the question wants to know, at what time is the greatest number of fish in the lake? Well, of those 3, the middle one's the highest, and that's at t equals 6.203 hours. Okay, here's where we can round it when we're given the actual answer, but you don't want to use that rounded value for time in your integral, because it could throw off your numerical values. The last part, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? and explain your reasoning. So is the rate of change increasing or decreasing? We want to know. That's basically saying, is E of t minus L of t, because that's the rate of change, the rate at which they're entering minus the rate at which they're leaving. Is that increasing or decreasing? So the way we look at it is we have to look at the derivatives of E and L. So we look at E prime versus L prime. Since E prime, the rate of change of the rate at which they're entering is negative, and L prime, the rate of change of the rate at which they're leaving is positive, since the rate of change entering is less than the rate of change leaving, that means the rate of change leaving is greater, so the rate of change of the number in the fish in the lake is decreasing because the leaving is greater than the entering. So that is a good example of an in-out question, and yeah, there we go.